Welcome to a new episode in our video series Demystifying 5G, brought to you by Rohde and Schwarz. So the last time we talked about how a mobile device accesses the 5G NR network, and that it's being instructed by the network to measure the signal quality on 5G NR cells that it is surrounded by, and using for that measurements the synchronization signal blocks. So we talked about some details of the synchronization signal blocks. And I mentioned that the mobile has to measure RSRP, RSIQ, and SINR on the secondary synchronization signal that is part of these synchronization signal blocks. So that principles, of course, can be now used to test also the coverage, the performance of the network. And for that, you're using, for instance, a Rohde and Schwarz TSME6 ultra-compact network scanner, like that I brought you here. And I want to demonstrate that measurement capabilities to you today. So we're using as a base station emulation here our SMW200A vector signal generator. I configured a signal at 3.5 gigahertz, one of the initial bands that 5G NR sub 6 gigahertz will be rolled out in, more or less globally, in Asia, in Europe, and even in the United States. It's connected to an antenna, so it's transmitting here at that frequency. And I connected an antenna also to our scanner, and I'm picking up that signal and do the measurements. So to display those measurements and to control the scanner, we're using our ROMES drive test software, and the ROMES drive test software is also displaying the measurement results. Let's take a look. As you can see, the measurement is already running here within the 5G NR option that has been recently added to the ROMES drive test software. So I'm showing you two views here, a bar chart here on the right hand side, but let's start with the top N overview of the measurement results that you see here on the top left. We basically have the signal with displaying the PCI here, the physical cell identity, coming with the primary and secondary synchronization signal. And then the most important thing that we talked about that we use to assess initial network coverage is the SSB indices. So you see here 8 of them being displayed and measured, and for over them we're doing basically a linear average like it is required to assess the cell quality and our cell quality. And what you basically see here is then one RSRP value measured on the secondary synchronization signal within the synchronization signal block, the SINR as well as RSRQ. You see here I set the reference frequency. I will show you in a minute how we configure these results to do the scanner to take the measurement. And now you can see on the right hand side for each of these individual SSB index the measurement results itself. So we have 8 of them here. That depends on how many synchronization signal blocks are there, depends on the deployment frequency range. If it is above 3 gigahertz up to 6 gigahertz, there could be 8 of these SSB being transmitted. Below 3 gigahertz, there's only 4. And if we go into the millimeter wave frequency range above 6 gigahertz, it could be up to 64. These SSBs are beam formed, so the phone will do a beam sweep and measure those, or try to detect those and measure those, and basically is reporting back that information then towards the network. So, like I said, we can use this to assess network coverage because that's what the mobile is initially looking for. Coming back to the bar chart here, so you see basically 2 bars per SSB index. The left bar here is related to the left-hand y-axis and shows RSRP measurement results for that particular index, and then the second bar here that you see is associated to the second y-axis where we're displaying right now the SINR. You can configure this bar chart very simply here. Like I'm showing, you can only, for instance, say I want to only look at 5 of these beams. You see how my charge changes, and I can look at 64 if I want to. Of course, then it will be a little bit of an eye chart, but here you see I have 11 now being configured. And of course, like I said, at the deployment or demonstration frequency, we use 3.5. So there could be up to 8 SSB being transmitted. I'm doing that. So of course, I wouldn't measure any more if I'm doing it the right thing. And that's what you basically see here then also in the software. So I can also easily now change the hierarchy. Right now we would show these SSBs based on SNR values. And of course I can just go in here and say like, no, I want to do it based on RSRP, and immediately my bar chart is being reconfigured. What would be interesting, for instance, if you do a walk test, especially at millimeter wave, you may want to focus on one beam. Also, this can be done within the software. So let's take a look how we're going to do this. So you basically see here on top the PCI filter. So if I have multiple cells, but if I want to look at only particular beams of these cells, or SSB index in that case, I basically go in here and say like, let's take a look at the second SSB index at that PCI. That was 256. So voila, as soon as I do that, now I'm only doing this and would focus during my measurement only on that particular index, can identify where would be a beam switch, switch from one SSB index to the other one, and so forth. So quite some capabilities that you have here. The question is now how I'm setting up the software for this, but this is another topic in another video in our video series, Demystifying 5G.